Hello everyone, I'm going to introduce the adjusted R square or adjusted determination coefficient. As you may know, actually, that R squared or the determination coefficient is a measure for how well the independent variables explain the variance in the dependent variable. In other words, is how good is the model can fit the data. So adjusted R square is a modified version of the R square that adjusted for the number of predictor or independent variables in a model. So which means that if you have more independent variables in the model, you may get actually different value for R squared, and for that reason we have to adjust for this increased number of predictor. So R square, which is the determination coefficient, is always increasing when more predictor added to the model, even if they are not significant. What does it mean? If you have two independent variables, even if they are not significant parameters, they may increase the value for R squared. For this reason, we have to use the adjusted R square to account for the number of predictors, which helps to avoid overfitting by penalizing the addition of irrelevant variables. Let's see that how this can be working. This is a standard equation that is can be found in a mini text box, and when where n is the number of data points or the sample size, and b is the number of predictors or independent variables. So in this case, if you have regression fitting using this kind of simple data set here, you have two independent variable x1, x2, and you have one dependent variable xy. So in this case, you can see the statistics that you can get from Excel, and for variable one and variable two, where this is basically the independent variables, they are not significant in fact. However, you need actually to calculate, or basically the Excel give you two values, R square and adjusted R square. In this case, you can find that adjusted R square is less than the regular R square, because in this case, you actually accounted for the number of variables. In this case, B is 2, and the number here, this increased. So basically, it's shifting everything to be lower than the value for R square or the regular determination coefficient. This is the same actually data set, but eliminating the x2 and use only in the one independent variable x, you can also get value for R square and adjusted R square, and R square adjusted is also still less than uh, R square. However, the independent variable in this case is significant when if you look at this table here, you can find the p-value is significant, in fact, for just one uh, independent variables. With that, I hope this is useful for you, and see you next time. Thank you.